Example 4 and 3.3 is a really good one where it talks about what we call optimization. And it is the idea that, by changing the price, we typically get more people to buy an item. If we put the price down. So if we increase the price, we might charge more per the item, but we typically get less people buying it because it's more money. So for A, the function to model the situation is actually pretty tricky. And really what we're doing here is we're finding the revenue. And basically, we are going to manipulate the price and see what happens. So initially, maybe I'll write this. Revenue is really defined as the price per item multiplied by the number of items sold. Right? That'll give you the revenue in any situation. So what we're going to do is we're going to identify that it says for every $1 increase in the price. So I'm going to say that X is equal to the number of $1 changes in price. So if X is positive, it's going up. If X is positive, it's going down. Or sorry, if X is negative, it's going down. And what we're going to get then is revenue as a function of X. So the price we charge was $10, but I'm changing it by X. So it's now going to be 10 plus X. The number of items was 400, right? 400 sessions were booked. So at $10, we would sell 400 sessions and make $4,000. But it tells us that for every $1 increase in the price, so for every X, we're going to have 20 fewer sessions booked. So it means if I increase the price by $1, this 400 session is going to be done by 20, and that's going to happen X times. Now, I would encourage you to make sure that your formula works. So let's say we made X2. So we've increased the price by $2. Well, the new price is 10 plus 2, so 12 bucks. That makes sense. And then because we're losing 20 sessions per $1 increase, we would have 400 minus 20 times 2, so we would only have 360 sessions. Because basically each time the price goes up, less people are willing to buy this service. So this is the function modeling the situation. And the next part, it says for B, what is the maximum revenue they can expect based on these estimates? And then what session fee, what price basically will give that maximum. Now, in order to do that, we are going to push the 3.3 technique, which is completing the square. In order to complete the square, I need to have this in standard form, so I need to expand it. I'm going to do that with the distributive property. So the 10 multiplies onto both terms. I get 4,000 minus 200x. Now the positive x multiplies onto both terms. I get plus 400x minus 20x squared. So I'm going to write that my revenue function is equal to negative 20x squared plus 200x plus 4,000. Now, what I do know from this form is that if I don't change the price, I make $4,000. And that's the y-intercept of our R of x function. And that's fine, but we kind of already knew that, right? 400 sessions at $10 a piece. What we want to find out is how can I manipulate the price to get the most money possible? And really what that is the vertex. Now, in previous real-world situations, we've often identified the restrictions. That there isn't a restriction other than the fact that if we make X, I think it would be 20, we wouldn't sell any sessions whatsoever. And that's a bit of an issue because then you don't make any revenue and you can't really sell negative sessions. Typically, we would use the graph for that. So what we're going to do now is we're going to complete the square for R of x. And I'm going to do that by factoring out the coefficient on my x squared term. And I'm going to factor that off of any term that contains an x. And I'll leave the constant alone. So just really quickly, negative 20x squared divided by negative 20 is 1x squared. 200x divided by negative 20 is negative 10x. All right, now within that bracket, and I'm going to use the same technique I did in the previous example, I am going to take whatever the coefficient is on x, and I'm going to add half of that, so divide it by 2 and square it. Then I'm also going to subtract half of that, so divide the 10 by 2 and square it within the fraction, the bracket, and then I am still going to add 4,000 after all that is done. Now, I always think it's important to see all these steps. I'm going to say that R of x is therefore negative 20 times x squared minus 10x plus, so 10 divided by 2 is 5, 5 squared is 25. You have to make sure that you're adding and subtracting the same number within the bracket. And then really importantly, I don't want that negative 25. It's messing up my perfect square trinomial, so I'm going to multiply by the number in front of the bracket, which is negative 20 for this question. And I now have that R of x is equal to negative 20 times, I'm going to write it as x squared minus 10x plus 25. Negative 25 times negative 20 is positive 500 plus 4,000. That's still there. Now I can factor it, and I get that R of x is equal to negative 20 times, that's going to factor into x minus 5 squared, and I'm going to have plus 4,500. Now, what this tells me is that my vertex is at 5 comma 4,500. Now that is because the A value is negative, that's a maximum. So this is corresponding to the maximum on my graph. Now what this means is I make $4,500 of revenue if I increase the price by $5. That's a weird looking 5. We'll try that again. So because my vertex is at 5 comma 4,500, that x score under the vertex, because it's positive, is how much have I increased the price by. Now, another way to look at this is if I charge $15 per session, I went to lowercase there for no real reason. But the other consideration is how many sessions would I have? And if I scroll back up, we identified that the sessions were 400 minus 20x. We now know that x is 5, so I would have 300 sessions. Now, I would encourage you to check that. If I have 300 sessions and I'm charging $15 per session, does that give me $4,500? And it definitely does for this question, so we've done it correctly. All right, I think there was a little more. It says, how can you verify the solution? You could graph it, nothing wrong with that. And then the assumptions that we made, and this is a big assumption. We are assuming that every time we increase the price by $1, we get 20 less sessions. Well, what if once we get past $20, for each $1 increase, we lose 50 sessions? Right? At some point, we're going to price out completely and nobody is going to buy a session. So we're going to be making $0. So there's a pretty big assumption in this question that kind of, dollar increase to less sessions is really a constant rate, which very often in reality it's not. Although definitely this question more than anything is just trying to show that we can complete the square to garner some pretty important information about questions.